Alright, for number 10 we have three limits that we're supposed to compute. They all function a little bit differently. I'm not going to go into great detail about the kind of mechanics of it, but we'll talk about it conceptually. So the first one here, we have this bit, and we notice that when we take 0 and we plug 0 in, we get a 0 over 0 situation. This is a good candidate for L'Hopital's rule, which says that we can take the limit as t approaches 0 of the derivative of the numerator and the derivative of the denominator, and that will still be a good limit. Okay, when we do that the first time, we still get a 0 over 0. I didn't write it out, but you can kind of work through that step by step. Of course, you've got a product rule here that you have to deal with, and then this is just 2t. That's easy enough. Then we take the derivative again, so we can see here we've got the second derivative of our piece here. This is going to be a big mess that simplifies quite nicely when you put in 0. Spoiler, the numerator is 4, and then of course the second derivative of t squared is 2, and so when we have 4 over 2 we get our limit to be 2. Now the second limit is a similar situation, but we can actually do something a bit different to come to our solution here. If we just put in 0 over 0, we get, if we put in x equals 0, we get 0 over 0, and that's of course not going to give us something meaningful. But what we can actually do here, if you notice this form here, we can actually multiply by the conjugate here in the numerator and denominator. And when we do that in the denominator, the middle terms, since we'll have a multiplying by basically the same thing except with a plus in the middle terms will cancel, and then we'll have this bit squared and this bit squared. So when we square this square root, we have just 1 plus x squared, and then minus 1 minus x squared. So we'll have 2x squared in the denominator, and of course we have an x squared already here in the numerator, so those x squareds will cancel, and that's why we have a 2 in the denominator here. And then of course the x squared cancel, so we have left what we multiplied in the numerator here, and then when we put in 0 we get the square root of 1 plus the square root of 1, so we get 2 over 2, which is 1. And in the last one we have limit as n approaches infinity of this situation here. We can rewrite this. If I take this kind of division problem here, I get the 1, and then I'm left with, I change this to plus a negative. You could leave it as minus if you want, but so plus negative 2 over n and raised to the n power. Okay, when you come across a situation like this where you have your limit to infinity, you've got 1 plus something over n, all that raised to the n power. This is going to be e to the whatever this number is here. So now you see that's a negative 2. That's why I did the plus negative 2. So we have e to the negative 2. And we have that limit. So that's one that's worth remembering. Maybe some other time we can go over why that is. But anyway, that gets us through our limits, and that finishes up homework 11.